Hi there! Today I'm going to be talking about ibuprofen and its relation to green chemistry. So let's start off by defining what green chemistry is. So a very nice and capturing definition is that it's the area of chemistry in which the focus is to design products to minimize or eliminate the waste produced in their making or to eliminate the hazardous products used to make them. There's 8 principles when it comes to green chemistry, and I'm just going to go over them real quick. So the first one is it's better to prevent waste before than to clean it up after the process. The next one is new pharmaceuticals use a lot of processes, and synthetic processes need to try and incorporate all the materials used. Synthetic should also strive not to generate toxicity to the humans or to the environment. Chemical products should also function effectively while not being toxic. Also, energy requirements should be recognized and minimized, or synthetic processes need to be ambient with the temperature and pressure. Next, raw materials should be renewable when practical. And after that, chemical products are designed to not persist in the environment or be dangerous. And last of all, substances used in a chemical process should be chosen to minimize the potential for chemical accidents. Now, after that, let me just give you a quick overview of what ibuprofen is. So I'm sure all of you have heard of it before because it is one of the most common over-the-counter drugs in today's society. It's used for things like migraines, anti-inflammation, arthritis, and similar things to those. Now, ibuprofen doesn't disintegrate in solution, so it can be taken as a pill or even used as a gel. It was discovered in the 1960s by the Boots Company in England. And what I will touch on a lot today is that it was originally made in 6 steps and produced a lot of waste, but recently it was able to be made into 3 steps to eliminate that waste. Now, let's go over one of the parts of green chemistry that it relates to. So it prevents waste in its making originally. So the Boots method, which was the one that was made in 6 steps, was made up of a lot of the recycling of the steps and corrosion, which used an excessive amount of materials. And in this recycling of steps, it would overall produce a lot of wasted chemicals and materials that would just be thrown out. Now, the Hotch method, which is the modern method, uses only 3 catalyst steps, and it has an 80% atom utilization as compared to a 40% atom utilization, which was what the Boots method had, which means that in the process, it prevents a lot of waste, and actually 40% more waste than it did originally. Now, the next process of green chemistry it touches on is that the chemical byproduct is not as toxic as it used to be. Now, ibuprofen does not have any salt formation in its process anymore. That means that it instead is produced through anhydrous hydrogen fluoride, which has a reaction selectivity and reduces a lot of waste. It actually reduces so much waste that it recycles with 99.9% efficiency, which is awesome. And there's no other solvent needed in the process to make it, so it minimizes emissions innumerably. The next process of green chemistry that ibuprofen touches on is that its energy requirements are recognized and they are minimized. So just like I said before, the Boots method was originally 6 steps, and it used a lot of recycling of products in steps, which just created a lot of waste. So obviously the chemists saw problems with that and worked to reduce it enormously with the catalyst processes. Now that means that there's less manufacturing and energy used in order to produce ibuprofen, which is awesome and helps the environment greatly. And the last process I decided to bring up in the creation of ibuprofen in relation to green chemistry is that it's designed not to persist in the environment. So it's an HF-based synthesis, that is used to make ibuprofen, and this results in a much more environmentally safe process that doesn't hurt the environment at all. However, it doesn't continue to be toxic, but the HF used in the process is still originally highly toxic and needs to be contained really well, otherwise it can be very detrimental. So even though the process itself isn't toxic and the byproduct isn't toxic, the original bit of it is toxic, and we are just researching ways to eliminate that toxicity altogether in the catalyst-based production and just make it much safer for us in the long run. So now that we learned about that, I just wanted to bring up a couple principles of green chemistry that I will try to persist to use in my life, or ways that I could use green chemistry in my life. So the obvious one is that I can easily do green chemistry in my life by recycling. So just recycling my cans, metal, plastics, and that overall avoids waste because it'll be reused and repurposed. I already actually do compost too, because I have a garden, and that is just a great way to make a greener beginning for new plants in the environment that I even plant. And last of all, even just to make sure just making sure that I don't use as many hair products in my everyday life, because hairspray can emit a lot of toxic gases and just isn't very good for the overall atmosphere.